41 tons of rubber, steel, and roaring turbines, lifting off the surface of the English Channel. Not flying, not sailing, something the world had never seen before, and after 32 years would never see again in regular service. The SRN-4 was the largest hovercraft ever built. It carried 418 passengers and 60 cars across one of the busiest, most unpredictable stretches of water on the planet. It did the crossing in 35 minutes. A conventional ferry took 90. And yet, it's gone. Every single one of them. Retired, scrapped, or sitting silent in a boneyard. The machine that made the English Channel feel like a puddle turned out to be one of the most spectacular commercial failures in transportation history. Here's why. To understand what went wrong, you first have to understand what the SRN-4 actually was. Because it didn't belong to any normal category. It wasn't a ship. Ships displace water. They push through it, fighting resistance the entire way. The SRN-4 didn't touch the water at all. It hovered above it on a pressurized cushion of air, trapped beneath the hull by a giant flexible rubber skirt that hung around the entire perimeter of the craft, like a thick rubber collar around the bottom of a bouncy castle. 4 Rolls-Royce Marine Proteus gas turbine engines, the same class of engine used in early jet aircraft, drove massive fans that continuously pumped air downward underneath the hull. The pressure of that trapped air column lifted the entire craft roughly 5 feet off the surface. Then, 4 enormous propellers, each one taller than a 2-story house, drove it forward. The result was a craft that weighed, when fully loaded, close to 310 tons, riding on nothing but pressurized air. Imagine a floating parking garage that had somehow learned to fly 6 feet off the ground at 50 miles per hour. That is not an exaggeration. That is what this machine did. Every single day, between Dover and Calais. To make sense of the scale, picture this. The SR.N4 Mountbatten class, the stretched version introduced in the 1970s, was 301 feet long. That is longer than an American football field, from end zone to end zone. It could carry 60 cars on its open deck and seat over 400 passengers in an enclosed cabin above. The entire thing rode on a cushion of air no deeper than the height of a kitchen counter. And it didn't arrive fully formed. The original SR.N4 that entered service in 1968 was already enormous by any standard. But British Rail and Seaspeed, the early operators, quickly realized the craft could be pushed further. The Mountbatten class stretch program in the mid-1970s added an entire new midsection to the hull, essentially slicing the craft in half and inserting a prefabricated extension. The result was something even more improbable than the original. A machine that had already broken every size record for hovercraft, made significantly larger, and still expected to lift off the ground on a cushion of trapped air. Now here's what a crossing actually felt like, because this is where the engineering becomes something physical and almost surreal. A vehicle drives onto the car deck at Dover's dedicated hoverport. Not a regular ferry terminal, a sloped concrete apron that ran straight into the beach. Because the SR.N4 didn't dock at a pier, it drove up onto dry land, and its passengers walked off onto solid ground. That alone was unlike anything else in passenger transport. Once loaded, the engine spooled up, all 4 of them simultaneously. The noise was extraordinary, not the low rumble of a diesel ship engine. The SR.N4 screamed. Those gas turbines produced a high-pitched roar that passengers described as standing next to a runway, while 4 jets prepared for takeoff, which is essentially what was happening. The rubber skirt pressurized, the hull lifted, and then the craft moved forward, across the beach, across the shoreline, and out onto the water. Without a wave, without a jolt, it simply continued moving, because to the SR.N4, the transition from land to sea was almost meaningless. The cushion of air worked the same way over either surface. Out in the channel, the craft reached its cruising speed of roughly 65 miles per hour. To feel that speed on water is deeply disorienting. Conventional ferries crossed the channel at about 20 miles per hour. The SRN4 was moving more than 3 times faster. The white cliffs of Dover shrank behind you in minutes. The coast of France appeared ahead while passengers were still finishing their first cup of coffee. 35 minutes. Dover to Calais. Faster than most people's morning commute. Here is the part that breaks your intuition about how something like this should work. The faster the SRN4 went, the harder it was to control. And the English Channel is not a flat road. It is one of the busiest, most turbulent stretches of water in the world. Tides run hard through that narrow gap. Waves build quickly in bad weather, and a craft riding on an air cushion has a completely different relationship with waves than a hull cutting through them. When a conventional ship hits a wave, the hull slices through it. The ship pitches and rolls, but the water is doing the work. When the SRN4 hit a wave, the air cushion had to absorb it. The rubber skirt would strike the wave face, the whole craft would lurch, and the ride could become violent in ways that shocked passengers who expected smooth sailing. In rough conditions, the SR.N4 didn't sail through the weather. It bounced across it. Passengers sitting in the forward cabin reported being lifted out of their seats. Motion sickness rates were dramatically higher than on conventional ferries. On the worst days, crossings were canceled entirely because the craft simply couldn't operate safely above a certain wave height. This mattered commercially. A ferry that cancels runs because of weather is a ferry that isn't making money. And the English Channel has a lot of weather. But the weather problem was only the beginning. Those 4 Rolls-Royce gas turbines that made the whole machine possible were also its financial death sentence. They burned fuel at a rate that would make a modern airline accountant physically ill. At full cruise, the SR.N4 consumed approximately 100 gallons of fuel per mile. Let that number sit for a moment. 100 gallons. Every single mile. The Dover to Calais crossing is roughly 21 miles. That means a single crossing burned through roughly 2,100 gallons of fuel. A fully loaded Boeing 747 burns about 5 gallons per mile per passenger. The SRN4's fuel cost per passenger, especially when crossings weren't fully loaded, was operating in a different financial universe entirely. Now, add the maintenance. Gas turbine engines designed for aircraft don't enjoy living in a salt air marine environment. Corrosion was a constant enemy. The rubber skirts that made the air cushion possible were consumable parts. They wore against the water, against debris, against the shingle beaches at Dover. Replacing a full set of skirts cost serious money and took the craft out of service for days. The skirts were also surprisingly complex. They weren't a single continuous piece of rubber. They were made up of dozens of individual segments, each one bolted and laced into position around the perimeter of the hull. A single damaged segment in the wrong location could destabilize the entire air cushion, causing the craft to list or bounce unpredictably. Maintenance crews became specialists in a type of repair work that existed nowhere else in the world. When those engineers retired, that knowledge largely went with them. The operating cost per crossing was enormous. The ticket price passengers were willing to pay had a ceiling. The gap between those two numbers never closed. For most of the SR.N4's commercial life, from 1968 through to the mid-1990s, that gap was manageable. Fuel prices, while high, were survivable. Demand for fast channel crossings was strong. The Hovercraft had something no other service offered, which was speed and the novelty of the experience itself. Passengers who crossed on the SR.N4 in the 1970s and 80s remember it with the kind of clarity people reserve for things that genuinely startled them. The vibration through the seat, the roar that you felt in your chest as much as heard with your ears. The bizarre stillness of looking out the window and seeing the English Channel rushing past beneath you without a single wave breaking against the hull, because the hull wasn't touching the water at all. It was a crossing that felt less like taking a ferry and more like being inside something that hadn't quite decided what it was. Then, November 1994 arrived. The Channel Tunnel opened for passenger service, and the entire premise of the SRN4 collapsed in a single moment. The tunnel didn't just offer competition, it offered a fundamentally different value proposition. No weather cancellations, no motion sickness. Drive on in England, drive off in France, with a 35-minute rail journey in between. Consistent, reliable, all-weather service at a price that the Hovercraft, with its fuel and maintenance burden, could not compete with over time. Passenger numbers on the Hovercraft routes began falling. The financial pressure that had always been manageable became unmanageable. Hoverspeed, the operator running the SR.N4 service, switched to smaller, cheaper to operate wave-piercing catamarans for their fast ferry routes. The giant SRN4 Mountbatten-class hovercraft, the ones that had carried millions of passengers across the channel over 3 decades, were retired. The last SR.N4 commercial crossing happened on the 1st of October, 2000. A small crowd gathered at the hoverport to watch it come ashore one final time. And that was it. The largest hovercraft ever built in regular passenger service retired without a replacement, without a successor, without anyone picking up the technology and scaling it further. One of the craft, the Princess Margaret, was moved to the Hovercraft Museum in Lyon-le-Solent in Hampshire, England, where it still sits today. Massive, weathered, unmistakable. The other Mountbatten-class craft, the Princess Anne, was scrapped. What remains is a genuinely strange legacy. The SR.N4 proved that hovercraft technology could work at enormous scale. It proved the crossing could be done in 35 minutes. It carried over 100 million passengers across the English Channel without a single fatality. That safety record is extraordinary for a machine operating in those conditions over 3 decades. But it also proved that being the fastest, most exciting option is not enough if the economics never fully work. The SRN4 was a machine that needed cheap fuel, calm weather, and no tunnel. It got none of those things in the long run. There is something almost philosophical in how it ended. Not a disaster, not a mechanical failure, not a dramatic final crossing, just a quiet arithmetic. The numbers stopped adding up, and the most spectacular ferry ever built was parked on a beach and left there. The English Channel crossing still happens today, millions of times a year, through the tunnel that replaced everything the SR.N4 stood for. But the tunnel has its own extraordinary engineering story, one that starts not on the water, but underneath it, with a boring machine the size of a cathedral nave cutting through chalk marl 250 feet below the seabed. That story is just as strange and just as counterintuitive as this one.